So here's the last slide on exponents, and again we'll look at this one because it takes a lot of pieces to get to here, and I thought an explanation, even though you have the answers, an explanation would probably be really helpful. So in this case here, you got 9a to the 8th b to the 5th over 3a cubed b squared all to the 2. Now BEDMAS would suggest we have to simplify the brackets as much as possible before we deal with the exponents. So let's start by simplifying the brackets. Okay? So in the bracket, I have a 9. Okay? Now I got a to the 8th and a cubed. See, I have the same base. We look at those in isolation, and I am subtracting because of the division. So if I was to look at this separately, we'll get a different color here. If I was to look at this separately, I would say, okay, 8 minus 3 gives me a to the 5, right? So there's no difference just because it's in a bigger question. We look at the a's and we say that's a to the 5. Same thing with the b. Just look at the b's. I'm subtracting 5 minus 2 because I'm using that division or quotient rule, and that gives me b to the 3. Okay, all to the 2. Okay, so that works a little better. That looks a lot cleaner. Okay, now what we can do is we can say, well, we'll get our green out here. Remember the 2, the exponent outside the bracket needs to apply to everything inside the bracket. Okay? So it's like saying, and you don't ever have to put this line here, but it's like saying I got 9 squared, a to the 5th squared, and b cubed squared. That's basically what we're saying, right? What we're saying is that 2 applies to everything, okay? So you don't have to show that line, but you can. It's helpful because 9 squared, 9 times 9 is 81. A to the 5th squared, well, I got 2 exponents together, so I have to multiply 5 times 2, gives me a to the 10. Okay? And then this one, same thing. I have 2 exponents together, so 3 times 2 gives me b to the 6. So my answer, and I'll just step off screen where you can have a look at it, is 81 a to the 10, b to the 6th. Okay? And that's how we got that first one. Let's look at the second one. The second one's even messier, okay? But we're going to deal inside the brackets first, right? Now, 8 and 20 doesn't work out so great. Okay, the best we can do with the numbers is reduce them, okay? And we can say, hold on, they can both be divided by 4. Okay? Both be divided by 4, so I could have 2 and 5. Instead of 8 and 20, I could have 2 and 5. Okay? Now, let's look at what else I have here. Well, I have the x of negative 3, and remember this x here without an exponent would be an exponent of 1, right? So the x's, I have negative 3 minus 1 gives me x to the negative 4. And they always go on top to start, and then we worry about it later. They always go in the numerator first. Same thing here, y to the 10 and y to the negative 3. Remember, we're in this situation where it's 10 minus negative 3. 10 minus negative 3 is like saying 10 plus 3, right? So that would be y to the 13, okay? All to the negative 3. All right, so now we'd like to make all of our exponents positive, okay? So let's start inside here. 2y to the 13 is going to stay in the numerator, right? But, and let's have a look to confirm it here. So this is a little different than on the slide, right? This is 5x to the 4th because that x to the negative 4th has to come to the denominator to make it positive, right? Now I'm doing it a little differently than the slide to show you a different way to do it. On the slide, I actually flipped it right away to make this positive, but I'm waiting to do that at the end on this one. Okay? All right. So now, because this is a negative exponent we have to take the reciprocal or flip the base. Right? 5 to the 4th, 2y to the 13th, and that's the exponent of 3. See how we took the reciprocal, okay? Now if I look at the slide, okay, I took the reciprocal at the very beginning, okay, which is fine, right? It doesn't matter if you take it here or if you take it there. I thought I'd show you both ways. So now we continue, and this 3 has to apply to each piece, and there's 4 different pieces as it turns out, okay? So we do 5 to the 3. Well, 5 times 5 times 5 is 125. We do x 4th to the 3. So those two exponents are tight together. So that's x to the 12. We do 2 to the exponent 3, which is 8. And we do y to the 13th to the 3. Well, those are tight together, and I'm going to show you an extra line why it is in a second. Those are tight together, so that's going to be y to the 39, right? So have a look at that for a second. Okay. Now, I could add in a line here that might help. If you're like, how did all this get to that? Basically, what we need to do is take y to the 3, x to the 4th to the 3, 2 to the 3, and y to the 13th to the 3. And that's what I mean by the green markings that say this exponent 3 on the outside needs to apply to every piece, right? So if I apply it to every piece, then I can see, well, 5 to the 3 is 125, but I can see these two exponents tight together, which means I have to multiply them. And I can see these two exponents tight together, which means I have to multiply them. So, and we know 2 to the 3 is 8. So that's how we end up getting there, okay? A bunch of steps there. That's as hard as it can get. Will most of the questions on the test be that hard? Absolutely not, right? But I didn't want to not show you a difficult one so that you, because I needed you to see it, I wanted you to see it. But again, might there be one question on the test that's difficult like this? Yes. Will there be a bunch of questions difficult like this? No, not at all. Okay, the questions will be more straightforward. They won't be this difficult. There might be one this hard, right? There might be one that hard, and the others will all be easier than that. So, okay. I hope that makes sense. Again, if it doesn't, jump on Wednesday when we're in week 9 on the tutorial and ask the question or the help session or send me an email. Okay?